All right, so what you need to have in class tomorrow is a box plot of these dot plots that I made. So we made these dot plots a while back. What I would do now, if you don't have the dot plot, and that's the reason why you weren't able to make the box plot in class, is to stop, copy down the number line. So you're going to need, oopsie, so you want to go down there. You're going to need to have two number lines, one up top, one on the bottom. One is describing the 2000 data and one is the 1975 data. And so notice each dot is just ticking that there's a temperature that fell in 2000 between 30 and 35 degrees. This is saying that there are two temperatures in 2000 that fell between 40 and 45 degrees. And for example, this here is saying that in between 60 and 65 degrees, that occurred 1, 2, 3, 4, 5, 6, 7 times in 1975. So that's all that this dot plot is saying. It's just tallying up the amount of times a temperature fell within a certain 5-degree range. From here on out, you're going to follow these steps to create a box plot. We're going to do the 1975 one first down here. The first thing you need to do is locate the median. The median dot is just as simple as it can be, the middle dot. So whatever method you can come up with for finding the middle. I, for example, know that I have 35 dots on here. So what I'm going to do is just count the first half of that. So half of 35 is about 17 and a half, so between 17 and 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Here's 17, here's 18. So our median is going to be right around here. It doesn't matter that it's not exact, because all we need to do is draw a single vertical line right here. Actually, I'm going to use the actual line here. I'm going to draw a single vertical line that's going to essentially describe where the median is. The median falls somewhere between 60 and 65 degrees. So there's my first vertical line. The second part of making a box plot is to make the same sort of line over both the minimum and maximum value. So again, the minimum value is obvious. It's this guy way out here somewhere in Alaska, and it's 13. It was 13 degrees, I remember from the chart, but all it matters is that it's somewhere between 10 and 15 degrees. And so I draw another vertical line for the minimum. I do the same for the maximum. I don't know what these temperatures are other than all four of them fit between 80 and 85 degrees. So it doesn't matter which one I decide is my max. I just know that my maximum temperature sits between 80 and 85, so that's where I put my other vertical line. The next step is what people seem to be challenged with the most. What you have to realize is that on this side of the median here, this right here is your median. I'll just abbreviate median, which is your middle. So half of the dots here fall on this half of the median. So this is 50% of it, and the other half fall on this half. This is another 50%. So what we need to do next is find basically half of half, or a quarter of the data. So saying that this, if you remember, was our split point between the median right here, we need to find the halfway between the lowest and this guy here, and then we need to find the halfway between the highest and this guy here. So we need to find that middle range again. So if I said that there's 17 here and 17 here, half of 17 would be 8.5, so we want to be somewhere around 8. 1, 2, 3, 4, 5, 6, 7, 8. It's definitely going to fall right around here. I don't know if it's necessarily this one or this one or this one, but it's definitely going to be between the 55 and 60. So I'm going to draw yet again another straight line here. All right, and that's called your first quartile. Your first quartile. And it's marking the end of the first 25%. It's going to be this guy here. So basically, everything here is the first 25%, right? Half of the half. Everything here is the second 25%, which makes sense because it's 25 and then 25. So we got 25% here, 25% here, and 25 and 25 is 50, and that's going to be our median right there. But actually, I want to get rid of that. Let me just draw over it in white so it's not here anymore. I think I can, yeah. And then you do the same on the other side. So on the other side too, you're going to find your line drawer, and you are going to find the middle of the top group here. So that's 1, 2, 3, 4, 5, 6, 7, 8. I don't know if it's this one or this one or this one. It doesn't matter. It falls between 70 and 75. So we're going to draw one last line right here between 70 and 75. And then to make that look like a box plot, you go to the minimum side here and you draw one straight line connecting it to the first quartile. And I should mention too, this guy here is your third quartile. I'll just say quart. So that's your third quartile right there. So you do the same thing from the third quartile to the maximum. So the outside 25%, this 25% here, 25% to, or 0 to 25% of your data points are going to be this line, and then 75 to 100% of your data points are this line. And then finally, you make the box on the outside, so you actually create a box right here. And this is your box plot, also sometimes called a box and whiskers plot, because of this guy here and this guy here kind of look like whiskers. Okay, let's practice that again. Let's do the same for this top one right here. I've got my first line is supposed to be marking my median, and so again I have 35 points, so I'm just going to count to 17 and a half. And I'm going to just hope that it's going to get me close. So that's 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it could be here, it could be here. I'm going to put the line right in between the two, just so that I split the difference essentially. So here is that median right there. And then I'm going to put my min right here. My minimum value goes here. My maximum value goes here. So I've made my first 3 points. I've split it in half. I've got 50% of it here and 50% of it here. And now I need to find the median of each of the two halves. So I have to find the middle again of this half. So it's going to be 8.5. 1, 2, 3, 4, 5, 6, 7, 8. 8.5 is here. 9 is here. It's going to definitely be here in that 50% range. So I'm going to go back to my line. I'm going to draw my red line here, right over this. I don't know why I said 50%. I'm sorry. 50 to 55 degrees is what I meant to say. And then we need to find our spot for this one here. So it's going to be the middle of this. 1, 2, 3, 4, 5, 6, 7, 8 is going to be around here between 70 and 75. So with my red line again, I'm going to draw the third quartile. Said it was between 70 and 75. That goes there. And then to finish it off, we just finish illustrating this diagram. We're going to go from the minimum to the first quartile with a straight line, and from the maximum down to the third quartile with a straight line. And then the middle 3 lines, we create the box. Just like that. And so now we have 2 different box plots describing data from 2000. Right, this one here is 2000. And this one here is 1975. Sorry, program glitch there. And that's what you need to have in class. You need to have this box plot and this box plot lined up so that we can compare. And what can we compare? Well, the range from the minimum to the maximum is much different in 1975 than 2000, right? This little space here, this space here is pretty drastic. This space right here is much less. That's the range. But the other term, the interquartile range, and that's going to be the range between these middle 50% here, is actually less on the 1975 than it is in the 2000. And we also see that our median and our max moved up from 1975. Here's our median here, and here's our max here. So we shifted a lot to the right, and we got rid of any sort of outliers here. But we also see that this actual middle box spread out slightly more. So that's what you need to have in class tomorrow, this and this diagram, which is based off of this and this diagram. So you should be diagramming. You should, by the end of this video, have this written down. Make sure you're pausing and rewinding as you need to. All right, I will see you tomorrow. Good luck.